So we are going to start off
Do you multiply by 3?
by multiplying radicals together. If you guys back here don't focus and take notes and stuff, I'm going to start a seating chart again.
Please don't.
We said the same
Okay,
thing.
so I have square root of 4 times square root of 5, right? I can multiply radicals if the index is the same for both things. I can multiply radicals together. We can multiply them together and put them inside the same radical. So square root of 4 times the square root of 5, what's the index on both of these?
3.
No.
1.
No.
2.
2.
What's that?
Remember,
Two
square root has an
always.
index of 2.
Oh.
We just don't write it kind of like if I have an x, there's number
Right,
1 in
somewhere
front, we
there.
just don't write it down. So square root of 4 times square root of 5, I can put these together inside one square root. And inside here have 4 times 5, which is really square root of 20, right? So as long as the index is the same, you can put them together. If I'm going to look at part A here, and I'm going to multiply these together, are my indexes the same?
No.
On part A?
No.
What index is right here, did we just say?
2.
2, right? Square root of 3, or excuse me, the cube root of 6 times the square root of 2, we can't multiply together. The indexes are different.
How do you
So,
know what the radical is? Like,
see this number right out in front?
yeah.
That's your index. And that's how you know what kind of radical. So this is a cube root because the index is 3. This is a square root because there's nothing there, which makes it automatically a 2. These ones over here on the right are, my thing shows up, are fourth roots. And the index is 4. Alright, so we cannot multiply. So I'm just going to go not possible. Because they don't have exactly the same index. So I'm going to look at part B. I have cube root of negative 4 times the cube root of 2. I can put those inside one radical and get the cube root of negative 8, right? And after I do this, it is kind of nice because when I multiply, sometimes I can simplify better. Because, let's see, you got decimals right there. What's the cube root of negative 8? Look at it real quick. And we get negative 2. So sometimes we can multiply these together and we can actually plug something in. Because if you plug in the cube root of negative 4, you get a decimal. You plug in the cube root of negative 2, you get a decimal. But you put them together, you get cube root of negative 8, and they both work. They get you a nice number.
What if it's just a normal square root and then you can't solve it?
Nope. Can't do it. And a pen, Thomas, that's it.
Perfect. No.
Did you see that?
Alright. So, I want you to do your first in-class problem. I want you to simplify this in the box as much as possible.
As much as possible.
As much
I
as
need
possible.
some assistance.
I feel like...
Do you want us to use the decimal?
No, if you get decimals, don't write that down. So
Write it
simplify
down.
as much as possible without decimals.
Thank you.
Do I need that?
Yes.
No.
Wait, are you pretty sure?
You shouldn't for this one.
No, you're sorry. I said I need some
I thought it
assistance.
was... If the index is the same,
Or I have to take them
you
apart
can
too.
put together two radicals. So this is both square root, right? We can put these together into one big one. You do 4 times 5 is 20, right? That's really square. These, the indexes are different. That's a 3, that's 2.
So it's not right.
Yep. But 3 is 3, you can put them together 4 times, negative 4 times 2 is negative 8, right? And you can actually plug that into decimals, so you just get negative 2.
So what? We just do up to the minute before then?
Yep. And don't forget to write your index of 4. Because they're 2 square roots. If you use square roots,
Just write it for the meeting.
Just did our stuff.
Yeah.
And
Yeah, you did. You got it.
And you just keep it as that?
chicken
Uh-huh.
and rice.
So this decimal, just leave it how it is?
Yeah, without the decimal.
How are you guys getting investment?
Because they're actually plugging it in.
Are you recording over here?
I think so. Pretty sure. Yeah, I'm recording.
What happens if we decimal?
So if you get a decimal, leave it as right before you got the
I
decimal.
see what you're saying now. Why?
All right, so let's go over this one, and what do you get, Helena? Since you're talking.
Okay, you should just
72
live
with
stream
the
your
four
lessons.
thingy.
Yeah, 4 3.
Yeah.
Or you could say index of 4, and then 72.
Which is, I don't know.
And about it dings. Can I plug that in and not get a decimal?
You get 2.92.
Yeah, you can. I'm trying to make him answer. I'm just saying. So if we plug this into decimals, we get a decimal. So we don't really want to write down decimals today, so we're going to leave it just like this. Make that my final answer. So if you gave me the decimal, it's not wrong, it's just, it's not as nice as this one. This answer is nicer. Okay. So we can put two radicals together as long as the indexes are the same. Well, the opposite is true. We can split apart one radical to make two.
Why not 3?
I have, you actually could do 3 if you wanted, but it's not as helpful. You can split them apart as much as you want. So I have square root of 24, right? So 24 is the same thing as 4 times 6. So I'm going to just rewrite 24 to be 4 times 6 in here. And then I'm going to split it apart into two square roots. My first one, I'm going to put 4. My second one, I'm going to put 6. And why would I do that? Like, what would be the point of that? Look at those two square roots.
1.
What?
Show the original problem was how, like,
We both can
Did
go
you
into
intentionally
24.
make this rhyme?
What?
Alright, what's the square root of 4?
2.
2. The reason we do this is because it helps simplify. The square root of 4 is 2, and the square root of 6 is a decimal, so I'm just going to leave it as 2 square root of 6.
He's the next doctor.
So, the reason we do this is because it helps us simplify things. So, the square root of 24, 24 is a pretty big number inside that radical. When I simplify radicals, I want as small of numbers possible inside. So if I can make this number on the inside smaller, I've done my job. And I did. My number on the inside now is 6. So I made that smaller, which is what I wanted to do.
Hey, what you got on Blender right there?
Nothing yet. I'm just doing tutorials. Getting ready for 3D printers.
Yeah, it's 3D.
Alright.
Wait, no, I was so confused. Where did?
No, it just goes in front.
Is that just supposed to be the little square thingy?
Yeah, the square thing right here.
Okay.
Alright, so let me give you another example. What if I did the square root of
17.
20.
63,
Oh, God.
right?
9, 7.
So, square root of 63. I can rewrite as 63 as 9 times 7, right?
Yes.
Which is nice because I can split it apart into two square roots
Oh, 3.
that I'm still multiplying together. Square root of 9 times square root of 7.
Wait, why would
But-
you want to split it again?
What?
Why would you want to split it again?
From here?
Yeah.
Oh, I split it because I haven't actually split it yet. I split 63 apart, and now I'm splitting into two square roots.
But why?
And you're going to see more why in a minute. But
Okay.
for right now, like what's the square root of 9 now?
3.
3. And
Square root
3
of
times the square root of 7, we just write as 3 square root 7 like this. It's kind of like if I had a 2 times x, that equals 2x, right? It works the same way with square roots.
2 backwards.
2 times the square root of 6 is 2 square root 6. 3 times the square root of 7 is 3 square root
Oh, it should
7.
just be this.
You just shove them together. So the reason we're doing this is because I'm going to simplify the cube root of 54x to the 5th as much as possible. So let's take a look at this. If I'm going to look at 54, can I cube root 54 and get a number without decimals?
what?
Yes. All right, what is it? Type it in, James. What's the cube root of 54?
You get
Bro.
So let's go over
It's
that real
It's
quick.
3.7. I'll
Yes.
show it.
Oh,
It is,
we're
okay.
confused.
All right. So we type it in and we get decimals.
Hold on, and then I go down to
Okay,
this.
so if you
We'll give James a minute. Let him catch up.
And then on the
Oh,
tab,
God.
Let him catch up.
it'll allow you to put the cube root in there first, and you have to click on the gray square. I already did it.
It's like a Lego hand.
Okay,
Under my light.
so we can't plug in 54 and take a cube root without getting a decimal. So, what about x to the 5th? Can I split apart x to the 5th to be something in parentheses, an x with some exponent to the 3rd and still equal x to the 5th?
No.
No, not without getting a decimal. So what I'm going to do is I'm going to split apart 54x to the 5th and into 2 cube roots. In my first cube root, I want everything with exponents of 3.
Is that 3?
You greedy.
Yeah.
You want everything.
I want my exponents to equal 3. Because what does an index of 3 do to an exponent of 3? Cancel out, right?
Go bye-bye.
And then I'm going to multiply it by a second
He's
cube
so
root
lazy, he doesn't take down his schedule.
with everything else. So what I'm going to try to do is I'm going to look at this 54. Alright, I want to say, how can I split up 54 to be something to the power of 3, and there should be a time sign right there, but I think I accidentally deleted it.
Another one.
I want to split 54 to be something to the power of 3 times something else that equals 54. And I don't really know what that would be off the top of my head, so I'm going to guess and check. So let's start with 2. What is 2 to the 3rd?
A number.
No, what is it? You got decimals right there. What is it, Austin?
I don't know. 16.
8.
8, right? Can I do 8 times something and get 54? No, that's how it doesn't work. So I'm going to try 3 this time. What's 3 to the
Very
3rd?
close enough. 6
Nine.
4 is minus 10.
No,
There
that's 3 times 3, not 3 to the 3rd.
12.
3 to the 3rd is not 12.
27.
27. Can I take 27 times something and get 54?
No.
27 times 2.
27 times 2 is 54, right?
God.
So what I'm going to do, just gotta sit back for a little while, James, and not blurt out answers.
Quick and fast.
Yeah.
12.
So,
I have a
3 to the 3rd is 27. 27 times 2 equals 54. So what I'm going to do is I'm going to split apart 54 to be 3 to the 3rd times 2. And now I'm going to look at x to the 5th. I want to split apart x to the 5th to have an x to the 3rd times, how many other x's are left if I have x to the 3rd for my first one?
2.
2 of them, right? To be a times x squared. This is still x to the 5th. I have 1, 2, 3 x's here, 4, 5 now total with these ones. So it's still x to the 5th, but I'm going to split it apart to have an x to the 3rd there. Because I'm going to rewrite my problem now. So instead of 54, I'm going to go 3 to the 3rd times 2. It still equals 54, but it's easier to simplify. And instead of x to the 5th, I'm going to go times x to the 3rd times x squared. Okay, and I think I'm actually going to make it a little easier and do one less step and not quite do it like I was talking about before, but it's still the same process. All right. Oh, and this is, I forgot to put my cube root, right? Not a square root, it's cube root. Okay, what is this index of 3 going to do to this exponent?
Cross out.
Cancel out, right? So when something gets canceled out, it gets kicked out of my radical. So this 3 has an index, or this 3 has an exponent of 3, and it's going to get kicked out of my radical. Does this 2 have an index of 3?
No.
Is it going to get kicked out?
No.
No. What about my x to the 3rd?
Why did you
Yes.
get kicked out?
It has an index of 3 because I canceled out. So what we're really doing, and what I'm trying to do is shorten it up to make it easier, is we are really splitting these into 2 cube roots. The first one has exponent 3, and they both cancel out just like we did in our warm-up.
So why doesn't the previous lessons get kicked out?
It did. We just did it the long way.
Oh.
But when they got kicked out, like in our warm-up, they got kicked out. Did I have anything left in my radical?
I don't remember.
No. So we didn't even write it down. That's why. On this, we're going to have some left over. Okay. So this 3 has an exponent of 3, it gets kicked out. This x has an exponent of 3, it gets kicked out. What about x squared? Is that exponent 3? No. So it's going to stay inside. So what got kicked out?
3x.
3 and an x, right? Okay. I have a radical still. What's left inside my radical? 2x squared, right?
Yeah.
The 2 didn't get kicked out, x squared didn't get kicked out. So this is my simplified version. I have 3x cube root of 2x squared. I'm going to keep going over it, Helena. Don't worry. Alright, so we're going to practice this. This is most of what we're doing today. It's pretty much just this. So let's try another one. Let's simplify the cube root of 128x to the 7th. So we're going to start with 128. I'm going to split apart 128 to be something to the 3rd power, because my index is 3, times something else. And I don't know what that is off the top of my head, so let's guess and check. So start us off. So Helena, since you got your hand up,
Nope.
let's start with 2. What's 2 to the 3rd?
1 second, I gotta pull that up.
No problem.
1.44. Oh wait,
2 to the 3rd.
the other way around?
Yeah, the other way around.
Okay.
That was pretty quick though.
It's 9.
Is
that
You
right?
did 3 squared. You did this and not this.
Oh,
It's 8.
it's 8.
It's 8. Okay.
Anyways.
Okay. Can I do 8 times something and get 128?
No.
Yes.
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 All right.
You can?
If you're not sure, what's 128 divided by 8?
I
Cool.
don't know.
Desmo
Wait,
said
would it be 4 also though?
it would be. We're actually going to talk about that.
It's 16.
We get 16, right? 2 to the 3rd is 8. 8 times 16 is 128. Which, we are not wrong, but Kayla just said, wait, what about 4? So 4 to the 3rd is 64, right? You plug that in Desmos. We could do 64 times 2, and we get 128. Both of these work. 2 to the 3rd times 16 equals 128. 4 to the 3rd times 2 also equals 128. We want to pick the one that has the smaller leftover number. So my 2 is smaller. It's going to be left over. That is the one I want to pick. So even though this first one does work, I'm going to end up with a smaller number inside my cube root, so I'm going to use this one. So I want this number on the end to be small as I can. That make sense? Are you awake, Thomas? Alright. So that is what I'm going to split apart my 128. And I'm going to look at x to the 7th. I want to split x to the 7th apart to be x to the 3rd and something else. If I have x to the 3rd over here, how many x's do I have left?
4.
4, right? So my index is 3 though. Can I pull out another x to the 3rd from this one?
Mhm.
I can. I have x to the 4th. I can split that up to be x to the 3rd and x, right? So I'm actually going to split up x to the 7th to be x to the 3rd, x to the 3rd, and then x. And I'm not going to worry about x to the 4th because I split them up already. So we're going to have actually 3 things that are going to get kicked out of our radical. So I'm actually going to move this down a little bit just so I got a little, just so I have a little extra space.
Like front rice.
Yeah.
There we go. Alright, so I'm going to rewrite my cube root to be 4 to the 3rd times 2 times x to the 3rd times x to the 3rd times another x. And I need to go through and look at, we are almost done. What's going to get kicked out?
4, 2 x's.
The 4 is going to get kicked out, and then an x, and then another x, right?
Wait,
All of these
why?
are getting kicked out.
Because it has exponents 3.
Yep, because this has an exponent of 3, which is the same as my index. This has an exponent of 3, same as the index. This has an exponent of 3, same as the index.
So that's the same as the index, you have to get rid of it.
Yep, they get kicked out. They cancel out. They're opposites.
That's sad.
Maybe they're going to have a party outside the radical. It won't be as radical as the rest.
I got
Okay.
Alright, so I had a 4 got kicked out, right? And an x got kicked out, and a second x got kicked out. And what do I have left?
2 and an x.
I got a 2 and an x left, right? Alright, I have one last thing. What's x times x right here in front?
X squared.
X squared. So, you know what? I'm just going to cross this out and go x squared. Not that that's wrong, but this is the more simplified. So you could erase it or rewrite it, but I'm feeling lazy, and I'm just going to scribble it out. And that'll make this my final answer. Right here.
Oh wait. Okay, we haven't went over the one with the double. Okay.
No,
Why did I do that?
but we're going to do that one next. Alright, so our last one that we're going to practice together is we're going to simplify the square root of 28 x to the 5th y to the 4th. Let me get some more space. You guys can just write lower, but you can't. Alright, so let's look at 28. I need to split apart 28. So you guys are going to help me out. Alyssa, we're getting started. What do I want the exponent to be for 28 when I split it up? What do I want the exponent to be for 28 when I split it up?
Oh, I know.
What exponent am I trying to get on all of these things?
3.
2. Because what's my index on this? Alyssa?
Oh,
2. My index is 2. I want all exponents to be 2. Alright, so I need something squared that'll give me 28. So, Ermaya, what's 2 squared?
4.
Can I multiply 4 by something to get 28?
Yeah.
What is it? No.
4 times 6.
4 times what is 28? 4 times 6 is 24.
Shut up, Elena, you're
7.
no help.
So, 2 squared is 4, right? 4 times 7 equals 28. Okay. And then you might also double check a few extras and make sure, generally speaking, if this number is bigger than, or excuse me, is less than 10, you're pretty much good. You don't need to keep checking. So, we're pretty good on this one. Okay. So, this one is slightly different because I have an x and I have a y, right?
16 times 7.
So I need to split apart my x to the 5th, and I need to split apart my y to the 4th. I'm actually going to split apart 3 things. The 28, the x, and the y.
What?
Okay.
What?
Wouldn't 4 squared be 16 then times 7?
Oh, yeah. Yeah. I meant to write 2 squared. It equals 4. I'm just getting ahead of myself.
I was like, what?
Calm down.
Yeah, I thought it
I
would
wrote
be
down 4
crazy.
I get so
squared.
excited. I did it in my head, and I'm like, oh, it's 4. There we go. My bad. It's my first
Yeah, that
mistake.
is your bad.
First mistake all year.
That's
Literally.
I wish that was a new code.
Okay, wouldn't that be a 6?
What?
Oh.
Oh, we're going for 28.
Yeah, 28. Alright, so let's look at x to the 5th. Carissa, if I split it apart to be an x squared here, how many x's am I going to have left over?
4 or 3.
Are you Carissa?
I didn't hear.
3.
Don't tell me, Loki.
She raised her fingers because you were too loud. Alright, but Kayla, can I take out another x squared from x to the 3rd? Yep. So I'm going to split apart x to the 3rd to be another x squared with x to the, well, 1, right? Left over. I'm not going to write it, just x. So I'm actually going to cross out that x to the 3rd so I don't confuse myself.
Confuse yourself.
No.
Oh.
Alright, we're going to keep going. Thomas,
Yes, sir.
if I take a y squared out of y to the 4, how many do I have left over?
2.
And James, can I split this apart any farther?
Nope. No.
Okay. So I'm going to start rewriting now. So I got my square root. I have a 2 squared times a 7. I should have made my square root bigger.
Beneath my square.
2 squared times 7 times x squared times x squared times x times y squared times y squared. Yeah, that was annoying. Alright, we're going to keep going through. Elena, what's going to get kicked out?
Literally everything.
Yeah, the
Almost
2
everything.
and the x and 1x and then both y's.
The next.
It'd be easier to say what remains.
Y. Yeah. Alright,
Why did it-
so a 2 got kicked out. And then, Austin, if I'm kicking out an x and then another x, how many is that total? Let's simplify it.
X squared,
X squared, right? And then same thing with y,
y squared.
y squared. Dazen, what's going to be left inside?
7x.
Yep, 7x. That is the simplified version. Remember, it's simplified because the thing inside the radical
Wait.
is smaller than what I started with.
Loki,
Okay.
what happened?
Is that 2x
What?
squared and
Yeah,
y
2x squared, y squared.
There's two,
Need 7x.
there's 2x squared, so
Yeah, and 2 y's. Like, why don't you do,
both of them.
yeah.
What?
Because you only
You guys are
put, you put
confusing.
1 y squared when there's 2 y squareds on there. Does that?
Okay, oh, yeah.
The two
Okay,
Okay, I'm
disappeared.
gonna show
okay.
yeah,
Okay.
show
Alright,
you.
I'm kicking out an x, right?
Yeah.
And then I'm kicking out a second x.
Oh, that's all the x we have out there.
What's when I have two x's together? What is that really?
X squared.
Okay, same thing with y. Y and then another y, right?
Yeah. Okay, well, I was just, it
Y
was just
squared.
Yeah, but there's
weird
Yeah,
for a
now we're
second
working
because
with
there was
chromosomes.
two. You just forget about the
yeah, but there's
exponents.
4.
Forget about the exponents.
Yeah. Yes, there is 4 right here. We split it into two groups of 2.
Exponents cancel out.
And they canceled out because my index of 2, even though I don't writing it's 2, cancels out the exponent. Remember,
I think they
the
forgot that.
exponent is getting canceled out, and my base, my base is going to get kicked out. So when things get canceled out and numbers and variables get kicked out, it's just the big number here. It's
Go
never
to
the
class
exponent.
almost over.
Not
20
really.
minutes. 20 minutes. All right, it's your turn. Simplify 250, or the fifth root of 250, x to the 8th, y to the 6th.
Who do you think I am?
You're Alyssa.
You're listening.
Got you.
You're
No, finish that.
I ain't got
What,
no
what am I?
I'm gonna
I've
say
got this
jokester,
recorded.
but that doesn't sound. I didn't really like that.
Yeah,
You're a
wasn't.
jokester, like this.
Keep trying. Keep thinking. Come back.
I'll
I'll
come
come
back. Come back to me.
Roy, I have a question.
What?
What did you say about that?
Oh wait, never mind, I figured it out.
Okay, wait.
What'd you get?
Yeah.
Nothing yet.
I got 50.
And this is
What? So what?
So something to the 5th.
I didn't get the problem.
Alright, awesome. What's the answer?
I don't know.
Oh my god, dude.
Hold on, time out.
Supposed to
Count
be
it.
smart.
I was watching.
Just kidding.
You're on it.
Oh, wow, that is a very large number.
So that was 5.
Let's do 2
What did Jaden say?
times 32. 250, right?
Yeah, that's not
Divided by.
After you.
32. That's not. So
3, obviously.
You want to see 32 times something equals
250,
250, right?
right? Dang it.
I don't really know.
So one will work here.
How
4.
about you work backwards and do 250 divided by
What about 6? No, we're
Let's
getting
just do
higher.
1. 9.
Let's try 3 squared.
1 times 250.
Yeah, it
It works.
does.
Okay. Does that work?
I mean, that'd
No,
be
it
right.
wouldn't work.
You get a problem to go with it?
I wasn't listening.
1 times 250.
Alright, so as you guys are going through this, have you figured out a way to split apart 250?
Yeah, 1 times 250.
Well, if you kick out a 1, does anything change?
Yeah.
No.
The one's gone.
It doesn't. We could do that forever. We could keep splitting apart 1 times 250, 1 times 250,
You
and
only
kick
need to do it
out
once.
an infinite number. No, it won't work. Can you split apart 250?
No.
No. So 250 is gonna stay inside. It can't be split apart.
Wait,
So
what?
we're
No, I'm just kidding.
So it's
250 can't be split apart. So it's just gonna stay inside. It's gonna chill there inside. But your x and your y can be split apart.
So what?
So that's gonna get. They're gonna get some kicked out somehow.
So to if the 50, what is
The 250 because it's like if I had a. So like if I was doing
it's just 250x
up here.
cubed
Like
y.
in this one, I cube root of say 2. Could I split that apart and do something to the third?
No.
Yeah, same thing.
xy.
So it's gonna stay inside. That 250, he's just gonna chill inside.
So why can't you use 1?
He's gonna be so
Look, okay.
radical. Because
Look at
you could
this.
always do 1, always.
So what's wrong with that?
Because it's a waste of time. Nothing changes if you factor out a 1.
You can go 1
Absolutely nothing
to
changes.
the 5th, which is 1.
It's
times
like
250.
it's like adding
That's
0.
50.
You know, why don't we just add a 0? We can do that forever, and nothing will change.
Well,
Or if you add a
number
negative
will.
0.
Yeah.
No,
The number will get
it will
bigger.
never change. No, if we plus 0, no.
Negative 0. Add a negative.
What about a plus and minus 0?
Careful.
Because isn't that what 0 is? What, 0 is not nothing. 0 is
Okay,
something.
let's do this.
5, right? So if you have x5, on your left leg.
72.
What is that? 12 times
I
6?
think I did that wrong.
Wow.
Yeah, split them 6.
Oh, dude, I did, didn't I?
Yeah.
Yeah.
Sure.
Oh, look, I wrote on. No, they're
Yeah,
in there. I
sure.
just wrote them as X's.
So-
You can't
Oh.
do
I know, but I was
Better-
just figuring it out. What 2?
You want it to be It's x8, right?
72.
And I want to take
That
out
would
the
be-
x5.
5 times 5 is 25. 4 times 4 is 16.
It's still gonna be 8. total.
72.
We got 5 here. How many here? Here, 8.
16. Oh, we're getting close. It's 3. 9. 72.
So what do I put, just X, Y?
That's 3.
Okay, if you take out
That's 8.
y5, right?
Yeah, 3
How many are you gonna do
times
left over?
3 squared times 8.
And 4 squared.
So we are going to rewrite
3
this
times
out.
3 is 9. 9 times 8.
So 250 is gonna stay like that. We're gonna have x5, x3, y5 inside your 50.
So 3 squared, so 3 x y.
When you put the 8 in there too?
Where?
Basic.
Oh, yeah.
Oh, no way.
X.
You and me. I don't even know the words, I'm just trying to
Right, it's gonna get kicked out. Okay, kick him out.
Yeah, no kidding.
This isn't that bad.
It's pretty bad.
So when they get kicked out, what am I gonna have outside there now?
Do you like this movie?
It's alright.
Yeah,
That's it. You forgot to, that index of 5 cancels out the x. Just the x stays out. So it'll be x outside. Take it in y.
She's only here for like a month.
No, watch on.
What we got left?
It's 2 total.
There you go.
Precisely. I just
Preposterous.
hear precisely.
Shenanigans. Alright, let's go through and let's
Call on us.
have you guys help me out. Alright, we already said 250 can't be split
One.
apart, but let's pick somebody random.
Aw.
Maybe it'll be James.
I said don't to like random.
Wait, I have
Let's
a
pick somebody
question.
random. I'm thinking about
Oh
it.
wait, never mind. I'm not even on the same problem. Scratch that
Okay.
question.
Alright, well, let's see anyway, Kayla. How'd you split apart the x inside your radical here, right, before you kicked them out?
5x times x to the 5th
Yeah.
times x to the 3rd.
Can I do it?
Oops.
No,
It
wait.
was 17.
I'm so wait. Oh wait. Okay. Never mind.
Because you're.
Can't you break down the 5 more though? Or
No.
does it not matter?
You want it to be 5.
What do you mean?
Cancel it.
You want it to be the same number?
Oh yeah, because,
Oh, so, okay.
yeah, you want it to be
Why
the
is that
same as the
undefined?
index.
God,
So, and we can't split apart that
I'm
3 anymore.
tired of this math.
Alright, so we're gonna keep going. Oh, or Maya, how are we splitting apart y?
Do 5 to the 5th.
Inside your radical right here.
Do 5 to the 5th. See why is it in the 5?
And then-
That is whack.
See, 5.
Alright, so we can't split apart 250, but we can split apart the x to the 5th, x to the 3rd, and y to the 5th and y. So as we look at this, who's at that desk? Or that one. Oh, Alyssa, what's getting kicked out?
Everything.
No.
The X and the Y.
Yep, we're gonna have an x and a y get kicked out. So we got x, y out here in front.
That's like the max it can go.
You used to keep that up. Okay, so
You
that's
had
called
one
the
more
index.
confined.
Yep, we keep the index. So x and y get kicked out. I got 250, x to the 3rd, y left over.
1, 2, 3.
Oh, you
it's
don't
5
put times
billion.
Y?
Oh,
Oh, it's slow.
You could,
Okay.
if you wanted. It's
No,
not
I
wrong.
meant at the end.
Oh, you could do a times y inside there. That's fine. Yeah. Just like you could put a times right here too, because they're all multiplied
Look at
together.
that as 0.
It's kind of like, yeah, it's like having a 2 times an x. It's not wrong. It's just I'm lazy and like writing a 2x there. Same thing. All right, that's it. Start on your exit ticket. I will turn on Scretive and then give you your homework. You okay there, baby? Oh, well, you're about to be in luck. I'm gonna get you.